Assalamu alaikum everyone. Welcome back to the CodeCracker. Today we are diving deep into the pointers in C++, one of the most powerful concepts in the programming. By the end of this video, you will understand how pointers works and why they are useful, and also you know how to avoid the mistakes in the pointers. So let's get started with the pointers. What are the pointers and why we use a pointer? It is a still topic and it is a main topic, and it is an important topic in the C++ programmings. Um, let's work on the pointer. And first of all, you're seeing first of all it is used. First of all, you have to understand what are the pointers and why we use a pointer in the C++. Basically, you are seeing the definition on the screen. That little bit complicated. What is after reading this definition, I will explain in my words and also give a real life example. First of all, a pointer is a variable that stores the memory address of another variable. Basically, a pointer is a variable. It's also a variable that store, but its work is to store the address of another variable. Basically, it is type of variable, but its main target is store the memory address of another variable. Basically, memory address is the address of variable, and their both variables have different addresses. If, for example, if you're creating a multiple variable, every variable have different address. We just variable fetch the address of this just pointer fetch the address of the variable and provide to us. And why we use a pointer, it is used for patient memory management and enable the dynamic memory allocation. Dynamic memory allocation is another concept that we are going to cover in coming videos also. And it's also essential for data structure whenever you are going to work on the data structures. It is a essential topic because linked list is fully dependent upon the pointers. So that's why pointer is very important. I give you visual diagram example that are able to understand what is the pointers. Let's understand what is the pointer. First of all, I will create a diagram just using this red color. This is this is a box. Basically, this is a box, and in the system, the memory. This is a memory. Uh, just just consider this is a memory, that is a RAM that help to store the variable. Whenever we're performing any program, any execution, this basically help to store the variable. For example, if we have two variables a, b. This is the two variables that we have, and in memory in the memory, these variables have location, have address that help that target which location in the memory it is placed. This address is known as memory address. For example, in the RAM, the variable is stored in the form of block. For example, this is a block A. This is a block for A. That is that is telling this block is storing the A, and this is telling that it is a B, and it is telling it is a. Basically, this is the two blocks that storing the variable, and this block have different memory address that identify this is the different, and this is also different, that basically differentiate the both variable, and both variable differentiate. Basically, pointer fetch this address at what location the variable is stored. For example, if I uh, have this variable a variable, this variable has also have a different memory addresses. This variable has also have a different memory address like 0, 7, FF, EFF, 5, 4, 6, 7, E, 4, 0. Is these types of memory addresses simply pointer fetch this address in the form of hexadecimal. This address is the address at what location. It is a basically address of variable in the memory. This at this address the variable is stored in the memory because there are multiple variables is stored in the memory in the form of blocks. To identify which variable is stored in the memory is at what address this address is going to be fetched by using a pointer. And every variable have different memory address. This is address of a. If we consider the another variable that is b, this is b, and this is the different memory address of this is the different from b. This means this b is stored in the different location. Just pointer help to identify at which location the variables are stored. Let's move toward the next topic. That's first of all, to use the variable, we have to understand the syntax and declaration of the variable. Let's look at the syntax in the C++. We declare the pointer like this: int x is equal to 10. First of all, we have to declare here ptr holding the ptr. Basically, this ptr hold the memory address of x. This ptr is holding the address of memory address of x that having a value 10, and it point to x. It is pointing to the x, and to get the value through this address, we use the dereference operators. To get the value through this address, we use this difference operator. And to how we can get this value? Sorry, in this, to fetch this address of the variable, just we have to use the cout command and just use this static ptr to fetch the address of memory. This ampersand symbol, this is known as of operators that basically used to fetch the address of a variable, and this is a static ptr is the pointer variable that we declare the pointer variable using the static. And we don't use it with a different data type. Just we have to use a just we have to declare the pointer variable by using the static. After this, we just fetch the address of this variable by using this symbol. This will fetch the address of this x. But this simple variable, like if we use a simple variable like y, z, it will not able to print out the address of the variable. It's common. This will help. This commonly it can help. This basically a pointer variable is able to store the address of the variable. Any other type of value variables cannot store the address of an variable. For example, if I use their pt, sorry, if I use their a equal to, and this symbol, I don't know how to create this symbol. For example, this is a symbol, and this is y. This a value, this is a that is not able to store the address of this y, because only pointer can store the address of the value. The normal variable cannot store the address of the variable, and this help to target the address and fetch the address and provide, and this pointer variable that hold the address that uh, hold that will store the address variable. This will not able to hold the address because this is a normal variable. To make it hold the address, what we have to do, we have just used the static in the here, and then we can target it using a symbol that help to fetch the uh, address, and this use the y. Not able to hold the address because only the pointer variable can hold the address, and this able to fetch the address. That's, yeah, that is simple. Now move to the next topic. What is I already tell you this address operator. I already this address of operator. This is known as address of operator. This is operator that is known as address of operator. Retrieve the memory address of variable. Basically used to fetch the address of memory address of the variable. And difference operator. This operator make the variable a pointer variable that help to store the address of the that is fetched from this operator. A normal variable cannot hold this address. That's why we use the difference operator. Another topic is the pointer arithmetic operations. Pointers support the arithmetic operations like addition, subtraction. But remember, when you increment a pointer, it moves the next block, not just a next integer. Basically, it will move the next block, not just next integer. For example, there is example that is int a and static ptr, and this is holding the address of this a variable. If I use the increment with ptr increment, in using the ptr increment, it will move this address to the next block of memory address, and the it will not show the address of this block of address, it will increase and increment of block of address and move to another memory address, and this memory address will be printed. Another topic is that we can use pointers to modify the values. Pointer is allowed to pass the variable reference, meaning a function can modify originally variable directly. For example, instead of creating a copies of pointers, we can use this simple modify function that enable to just modify the pointer and print the modifier address of the pointer. Instead of creating a copies, pointer give the direct access variable inside the function, optimizing the memory's usage. And it will modify this pointer. First of all, look at this example: void modify int static ptr, that holding the this value 50 and ptr, and now x is this 10. X is now 10, and now we know that x value has been changed, and it will move to the x10. Now it will uh, now it will check the address of this 10, and it will modify, and x is now is 50, and it will modify, then now it will fetch the address of the 50. Another type is the double pointer. What is a double pointer? Basically, a double pointer is used to fetch of the address evenly. It is help to fetch the address of the pointer variable at first location. The pointer variable is storing the address of another variable. For example, we have using this. We are fetching the address of this x10. If we want to fetch the address of this pointer variable, at what pointer variable this address has been stored, we use this double static that help to identify at what pointer variable this variable is going to stored. Just it's going to print out the memory address of this pointer variable, not this address of this pointer variable. Basically, this is the variable that is pointer variable that holding this address. Now it's also have the address in the memory, and this double pointer is used to identify at what location this single pointer variable is storing the address of this variable. That is a simple concept of double pointer. And why we use the memory managing, why we use the uh, new and delete keyword in the using concept of pointers. C++ allows dynamically memory allocation using a new and delete concept. This means memory is allocated runtime instead of compile time. Always sorry, static ptr output, it will simply print out this 100 on the screen. If we use a new keyword, that will indicate whenever we're using a dynamic, if we are using another variable, by the runtime, the compiler should decide to declare the variable until the condition is matching. The new word is declaring the variable at the runtime, and this ptr is storing the address, storing this value in the form of storing this value, and this value will fetch the address. This pointer variable fetch the address, and delete ptr keyword is a basically keyword. For example, if I give you example. This is the block of memory. This is the block of memory, and this is the PTR variable, and that is stored in the form of block. When we use the delete keyword PTR, it will get deleted from the memory, and it will free up the spaces. It is more. This is basically a good concept that is used to free up the spaces in the memory. That's why we use the pointer here. That we use the that we use the delete keyword that free up the space in the memory, and it will empty the memory, so it will help in to run the program and execution in the fast. And the ptr 100, that is a new keyword. For example, if we are allocating the memory, this is a block of memory. We use a new keyword int. For example, we are creating a different um, we using a while loop that depend upon the condition. Until the condition is matched, it will automatically create the multiple pointers on the memory. If the condition get false, the creations of the variable get disappear or get finished, and only the certain variables are created on the memory. That's why we use the dynamic and memory allocations. that is it for the theoretical basis. Let's move toward the code, how we can write the code of the map. So let's move. Now we are working on the code example of these pointers. So simply I will use the essential libraries that we always use in C++. So simply I will write that, and after writing that, I will explain the code with line by line. So I declare the some essential part that we are always doing in C++ programming. Simply, first of all, to identify the location in memory, that the location at what location the variable store, we have to create a variable to identify. We have to identify the address of this variable. Now I will pass the value that is 10 to him, and 10 to this variable as the integer type. After that, passing the variable. Now you have to declare the pointer variable by using static ptr. This is a pointer variable. Now we are using the embrace symbol that basically used to fetch the address of this x variable. So I will use the x, so it will able to fetch the address of this x variable. And after fetching this address, the address will store in this pointer variable. Now simply we will print out the pointer variable. If I use here static ptr, what will be happen if I execute now? Simply what we have we done here, and just create a variable, and this variable and this embrace symbol that fetching the address of this memory address of this value, and after fetching it will store in this pointer variable. After storing the pointer variable, just we going to print the pointer variable. After compiling an execution, it will printing the 10. Why? Because it is printing the 10, it is not printing the memory address, because it only hold the value. It will not it hold the memory address, but it will print out the value. We use this static to print out the address of the value. We have to use the static. We have to remove the static from here. Then after that, we have to compile and run it again. You can see this is the memory address. At this address, the variable is stored in my system at some 065 such hexadecimal form. uh, to fetch the address of the variable, just we have to remove the static from the here and the cout function, but the names may, but this previous, but the it will remain same in the whole previous function. And that's how we can print out the result of a pointer variable if we use it by commonly uh, uh, because the creative because the PTR is a differencing PTR static PTR is a differencing operator that is static operator, and that fetch the value stored and the memory address. That only fetch the value of stored in the memory, but it hold the address of memory. It will hold the address of the memory, and also hold the fetch the value, and which is the 10. So it will printing the 10 after removing the static pointer. Now it's fetching this value memory address. So it will able to print out the memory address. To print out the memory address, just we have to remove the static from the beginning, receiver function, and print out the address. And if we want to print the value, we have to use the static. That is a simple concept of the pointer. Congratulations, you just have mastered the basics of the pointer in C++. We covered a declaration pointer and arithmetic memory management and best practice. And if you found this useful, don't forget to like and subscribe and comment below. Stay tuned for more coding contents on the CodeCracker. See you in the next video. Okay, Allah Hafiz.